So let me give you the definition of joint probability mass function of random variables. Okay, so joint PMFs of random variables is basically defined in this way. Okay, so suppose I'm interested in the joint PMF of x and y. Okay, so this is the notation that we'll be using. Okay, and the input is going to be x value and a y value. Okay, and so this is the notation for joint PMF, joint probability mass function of x and y. Okay, and this is the definition of it. Okay, it is probability that x equals x comma y equals y. Okay, let's do one example. Okay, suppose the experiment is the following: you toss a fair coin 3 times. Okay, suppose x is number of heads in the first 2 tosses. Okay, and y is number of heads in the last 2 tosses. Okay, and the question is basically find the joint probability mass function of x and y. Okay, so we want to figure out what is this function. Okay, so the way we can do that is the following: we can actually make a table. Okay, joint PMF table, and do that using a table. Okay, so observe that the x can take random variable x can take 3 values, 0 heads, 1 heads, and 2 heads. Okay, so these are x values, and y can also take 3 values: 0 heads in the last 2 tosses, 1 heads in the last 2 tosses, and finally 2 heads in the last 2 tosses. Is that fine? Okay, now the question is, what are these joint PMFs? So if I'll ask you, what is pxy00? So what is pxy00? Anybody? What is the probability that x is 0 and y is 0?
1 by 8.
1 by 8. Excellent. Okay, so when we say x is 0 as well as y is 0, means that number of heads in the first 2 tosses is 0, number of heads in the last 2 tosses is also 0. That means all 3 tosses resulted in tails. Okay, and the probability of that is 1 by 8. Okay, now what about this one? X is 0, y is 1. What is the probability that x is 0, y is 1?
2 by 8.
Why 2 by 8? There is only one possibility here, right? The first 2 are tails followed by heads. Okay, only then x will be 0 and y will be 1. So this is also 1 by 8. Yes, because tails, heads. Tails, heads is something which occurs with probability 1 by 8. Okay. What about this one? 0 heads in the first 2 tosses and 2 heads in the last 2 tosses. What is this?
Tail, head.
Tail, head is not correct, because if it is tail, heads, then x will be 1, not 0. This is 0, right? I mean, there is no way that you can get 0 heads in the first 2 tosses and 2 heads in the last 2 tosses. That's not possible. Is that okay? Okay, what about this one? What is the probability that x is 1, y is 0? So basically, you're tossing a coin 3 times, and you're interested in 1 heads in the first 2 tosses and 0 heads in the last 2 tosses. That is only possible if the first one is heads and the rest 2 are tails. Do you agree? Okay, what about this one? You want one heads in the first two tosses as well as one heads in the last two tosses. Okay, so how is that possible?
Zero, should be zero.
No, that's possible, right? I mean, if you get head, tails, head, that's one possibility. Other possibility is tails, heads, tails. That's another possibility. In both cases, X will be 1, Y will be 1. So actually, this is 2 by 8. Is that okay? What about this one? So you want one heads in the first two tosses and two heads in the last two tosses. This is only possible if you get tails in the first toss followed by two heads. The probability of that is 1 by 8. Okay. What about this one? 0, right? Because you want two heads in the first two tosses and 0 heads in the last two tosses. That's impossible. Given that you have two heads in the first two tosses, that means the middle one is also heads. And if the middle one is heads, then Y, which is the number of heads in the last two tosses, cannot be 0. Okay, so this is 0. What about this one? Two heads in the first two tosses, one heads in the last two tosses. The only possibility for this thing is, if you
Head.
have, yeah, heads, heads, tails, right? And that's 1 by 8. And what about this one? Two heads in the first two tosses, two heads in the last two tosses. This is only possible if you get all three heads, and therefore that's 1 by 8. Check that this is a valid PMF. Just add them up and check that you're going to get 1. Is this clear?
Yes, Professor.
Okay, now you can figure out the marginal of X. So this is a joint PMF. Okay, from this you can figure out the marginal of X in this way. So marginal of X actually tells you, what is the PMF of X. Basically, that's what marginal of X is. If you are given a joint, you have to figure out what is the probability that X takes value 0. What is the probability that X takes value 1? What is the probability that X takes value 2? So this is how you can do it. Okay, so I'm just going to put the marginal of X here. Okay, so how do you get, what is the probability that X is 0? Probability that X is 0 is 1 by 8 plus 1 by 8 plus 0, which is 1 by 4. Okay, probability that X is 1. So when is X 1? Well, X is 1 in these three possibilities. Okay, and if you just add them up, you will get half, right? Okay, and similarly, what is the probability that X is 2? It is 1 by 4. If you add these things. Okay, and if you want to figure out the marginal of Y, okay, now you want to figure out marginal of Y, it's the same thing. You figure out what is the probability that Y takes value 0. Probability that Y takes value 0 is just sum of these numbers. Okay, because Y is 0 here. Okay, you just sum it over X. Okay, and you will get 1 by 4. Okay, and if you want to just sum these, you'll get probably that Y is 1. Okay, which is half. Okay, and if you want to sum these, you'll get probably that Y is 2, and you're going to get 1 by 4. Is that clear? Okay, so this is Py. Have you all understood this? Okay, you can also see over here, this is exactly what you're doing. You're taking the joint, summing it over Y to get the probability mass function of X at X. Okay, that's exactly what we are doing over here. Is that fine?
Yes, Professor.
Okay, okay, let's do one more problem. Okay, and then we'll move on to conditional PMF. Okay, suppose you have an urn. Okay, it consists of 10 red balls, okay, and 20 black balls. Okay, so it has 10 red, 20 black balls. Okay, and what you're doing is the following. You're going to draw two balls from this urn, one by one, without replacement. So this is the experiment. Okay, you randomly draw 2 balls from the urn without replacement. Is that okay? That's the experiment. Okay, now let me define X as number of red balls. Okay, number of red balls that you draw in this process, and let I be number of black balls. Okay, can you tell me what is the joint distribution of X and Y? Okay, you just have to fill up this table with the joint PMF. Do it. Are you done? So what is this? Number of red balls is 0, number of black balls is 0. 0, right? I mean, it's impossible. You're drawing 2 balls, so obviously, getting 0 red balls and 0 blue balls is impossible. Okay, in fact, this is also impossible. Okay, this is also impossible. Okay, and this is also impossible. This is also impossible. This is also impossible. Okay, so these are the 3 numbers which we need to find. Rest of them are impossible, because the total number of red balls and black balls is always going to be equal to 2. So 0 plus 2 is 2, 1 plus 1 is 2, and 2 plus 0 is 2. So these are the only 3 boxes in which we need to put numbers. Okay, elsewhere it's 0. Is that okay?
Professor,
Yes or
for
no?
0x and 1y, why is it 0?
If you're drawing 2 balls, one of them is, let's say, a black ball and there is no red ball, is that possible?
Understood.
Okay, that's not possible, right? So what about this? What are the chances that you draw 0 red balls and 2 black balls? Okay, so what that means is, it is
BC2.
20 by 30. Okay, into, yeah, you can also write 20 choose 2 divided by 30 choose 2. That's another way. It's going to give you the same thing. Okay, so whether you write it like this or you do 20 choose 2 divided by 30 choose 2, you're going to get the same thing. Then it is 19 by 29. Is that okay? Yes or no? Alternatively, this is the same thing as
Why is it
20 chose 2 divided by 30 choose 2. That's the same thing. Okay, this is the same thing as this. Is that clear? Is that okay? Okay, what about this one? This one is 20 by 30. Okay, just a minute. Okay, in this one it is going to be
10C1 by 30C1 into 20C1 by 29C1?
20C1 into 10C1. Okay, the whole thing divided by 30 choose 2. Is that okay? Okay, alternatively, you can also write it like this: 20 into 10 divided by 30 into 29 divided by 2. So basically 2 will come on the top, because there are two ways, right? I mean, either you draw, first one is the red, second one is the black. The other possibility is first one is the black, second one is the red. Okay. So either you write it like this, or if you write in terms of order, then make sure that you multiply the thing by 2. Okay, what about this one? So you want 2 red balls, 10 choose 2. Okay, divided by 30 choose 2. Okay, you can easily verify that this is a valid joint PMF. If you want, you can check the sum. Okay, we can quickly check. Choose to 22. Okay, this is 20 choose 2 plus choose 21. Okay, times choose 10 1. Okay, plus choose 10 2. Okay, let's run this. Okay, you get a number 435. Let's compare it with 30 choose 2. Which is the same thing. Okay, so so this is a valid joint PMF. Is that clear? Okay, now if you want to figure out the marginal of X, that's actually kind of obvious. Okay, you just have to fill these up. What is the probability that X takes value 0? It is just this number, okay, which is 20 choose 2 divided by 30 choose 2. Okay, what about this one? Well, this is again 20 choose 1 times 10 choose 1 divided by 30 choose 2. Okay, and what about this one? This is again 10 choose 2 divided by 30 choose 2. Okay, that's the marginal of X. Similarly, you can figure out the marginal of Y by summing here in this way. Okay, is that clear? Okay,